MRI before. You probably perhaps have had one. They put you in a very large electromagnet, and you lay in there, and they energize that magnet. And what that magnet does is it's reading your body. It finds bone, it finds metal, it finds everything, you know, that are very definitive layers. The same thing is true with this technology. The energy is the sun, and the sun is obviously very powerful. Earth is very small, and this tremendous electromagnetic wave is completely bombarding the Earth. It goes around all sides. You've probably seen this on National Geographic, and it actually penetrates the Earth and goes all the way through. And on the dark side of the Earth, there's a shadow that emits 200 miles. And it's this shadow that we're reading. And we're looking, the Earth is a big magnet, we have an energy source. We're looking in that shadow for the spin of the elements, just like an MRI does. We triangulate that with other satellites to figure out exactly where it's at. Okay, so that's the very basis. So MRIs are identical to the technology that we're employing. Okay? So I'm going to show you from Google Earth.
It's crazy simple. It's simple.
So this is the target that we refined this target 12 years ago. We had a team that did a flight over this area, and we were looking at gamma waves. We found a very large gamma wave over this. There are actually several gamma waves in the area, and we decided to study it because one, it's on private land, so we don't have to worry about permits. You know, we're also involved in federal land, which is very onerous with governmental agencies. This one we thought, great, you know, let's find something on private land. What you see on the screen is the location that you're actually standing on. This is the well, and the location that we're on, you know, is indicating that we've got oil here from 74.67 to 74.84. This, by the way, this shot was done in 2019. And so we see, you know, we define the various elements in the layers by color. Okay? These colors are only colors that we make up. This is a bar, a sandbar, an ancient sandbar that filled with oil. Very common out here. There's about 150 oil fields in this area. They range, the largest is 88 million barrels of oil, big field. The rest of them, you know, between 1 million and 25 million in size. And this one here, you know, has about 8 million barrels, something like this, in this zone. The lower rust color is what we estimate is the dolomite. We can't be sure because, you know, the well control wells that were previously drilled in this area are not close enough to basically define this. I think I told you that previously the technology, we were in the Gulf of Mexico. This is an image of the Gulf of Mexico. This is where the technology was in a floating cable, NMR. We discovered using that electromagnetic 4 fields in the Gulf of Mexico. 4 major oil companies. The log that we actually drilled on this location, and by the way, we started April 1st here, just to put this into perspective. On April 1st, you know, this is what we had. A hole in the ground, ready to be drilled. That's Horatio DeCon. He's our petroleum engineer. He's on his way here. You'll meet him. He's from New Zealand. He's been all over the world, offshore, onshore. Very experienced man. This is the prognosis that I put together prior to drilling. we put this together based on well control. We look at wells north, south, east, west around us. We find out where they intercepted the zones. And of course, we correlate that with what our technology is saying. And you can see 7467, 7486 on this. And these are the Niobrara, all the sandstones. These are all the formations that we drilled through down to the 7467. And again, the one we're interested in here, it could be the Atoka. Based on well control, it should be Atoka, but based upon everything else we know, we think that it's a dolomite because it's so deep. When you go this deep, you go through all the sandstones, the shales, and then you get down to the basement. And the basement in this area is dolomite. Just so you know, dolomite as a formation is the largest producing formation in the world. The biggest fields that you may have heard about, Gwar, Saudi Arabia, is perhaps the largest that people are familiar with. It's 197 billion barrels of oil. Now, that field was discovered in 1954. And when the geologists who had been drilling all over the United States went to Saudi Arabia for the first time, they were invited, they saw these tremendous anticlines. It was 160 miles long. And they said, it's too big, can't be. I mean, it's just too big. And it wasn't too big. They drilled that. And those wells came in at 50,000 barrels a day. So everything that I'm telling you is based on dolomite. We don't know this is dolomite until we drill it. So as I said, that story could get better because the average dolomites in the United States and around produce thousands of barrels a day. You don't have to frack them. They are glugular. The very nature of the calcium, magnesium, when they come together, they produce almost petals like a flower. And they have infinite porosity, infinite permeability. They have 100% recovery, which means you're going to get all the oil out of that formation. Sandstones, you get an average of 25%. So, as I said, the story could get better than what we think. Okay.
What's the timeline to get down to something like that, just out of curiosity? Based on current...
It's a very good question. Normal drilling, is about between 100 and 300 feet per day. Okay. I have a proprietary technology. It's a magic mud that we drill with that we've tested in previous wells. And in fact, in this well here, we attained 300 feet per hour. There are always complications, and you can't always drill continuous because you have something breaks down, so you have to stop, right? If you have a part, you have to wait, you have to, circulate and wait for that to happen. But for continuous drilling, we should make it down on this formation in just a couple of days. And we hope that with this rig being a fairly new rig, being sitting there for 5 years, we hope we get all of the stuck parts unstuck and everything is moving in coordinating with the drilling, and we can be down in 1,600 feet. Theoretically, I could do it in 1 day. Okay. We're going to go fast enough to reach the formation, but not so fast that we drill a crooked hole. We're employing a mud motor, which is a motor that uses fluid, a stator, like a Archimedes screw, you probably know, which basically uses a screw and a stator, and it pushes fluid through. When that's attached to a drill bit, that rig is turning at 6 times. For every 6 revolutions that rig is turning, the mud motor is turning 60 times. So it is going like a very high-speed drill. Okay? And consequently, you can drill faster using this. So we employ mud motors on this, and we employ magic mud to drill faster. The log in this case I want to show you because you can see the date here is June 3rd of 2022. This was logged by Midwest Wireline. They actually logged this, they had to log it 3 times because we could not get the logging tool down. We had shales and we had a freshwater zone and it was swelling, and so although the tool is only a 3-inch tool and you got an 8-inch hole, it literally wouldn't go down. You can't force them down, it's on a cable, but they weigh 20,000 pounds and they should, go down, but it didn't. So we had to do it 3 times. This is the 3rd run. We could not get to the bottom, our key zone, which was the 7467. You can see this is the portion of log. This is oil. There's 7450. There's 7467 is right here. Okay, and this is the oil deposit that we hit. We also hit, and I projected in the Niobrara because I mapped this area. We could see faults. We know where there is. Niobrara is a shale. It's like a cracker, and when you compress it, it fractures all the way through. We had about 110 feet of gas in the Niobrara. Now, one thing about the Niobrara is Niobrara doesn't have gas. It's only an oil formation. It normally has no water, by the way. And so we know that the gas is migrating from below. It's charged that through the fractures. And because it has porosity and permeability, it's been fractured, it's filled up with gas. And it had a lot of gas. I mean, everybody extinguished their cigarettes, and we don't allow smoking on the rig, but even far away, that wave can go and you could start a fire. But you could smell gas all the way around the rig. And so we know we've got oil here, and we probably have enough oil in this one zone alone. If we were to stop today, run casing, and complete it here, it would be a small well, probably 10 to maybe 18 barrels a day. But if you do that on a continuous basis, you have about a year, 2 years payout. The average on oil and gas is 3 years payout. We're looking for something so big that we get immediate payout, fast payout, lots of production. We also found an occurrence of a lot of different anomalies out here. All these green anomalies are additional areas that we looked at, but not nearly as big as what we're drilling on. I mean, not even close. These may be 1 to 3 million barrel fields. But what we're looking below us could be a 100 million barrel field. And that's what our focus is as a company. We bought 4 oil rigs. We formed Archer Drilling Company. It owns this rig and 4 additional ones. This rig here has only drilled, I think, 4 holes before this time. So very good condition. We got it at a very good price.
Wow.
I will just briefly discuss some of the technologies that. Well, let me go to this one because I think you'll find it interesting and compelling. We mapped the water here, as Ronnie had said, and the area of the water is in blue, and the rust coming through is areas where the water is not. Okay, so we were originally going to drill right here, okay, right where it says oil 74. That's where our location was. But I moved it down here because I didn't want that into the water zone. I didn't want the incursion of water while we're drilling. But I wanted a water well close enough that we don't have to go for miles to get water, because water is very expensive to ship, to move. It's heavy, and so I picked the water just south of the 19 to 273 feet of water. And Gene is the best witness because he was there when he drilled it. The water well driller didn't think there was any water here. He said, "There's no water here." He was feeding water to it the entire time. And even Gene said to me, "I'm not sure, James, there's any water here," because the guy said there's no water. I said, "Gene, just tell him, leave that well and put a pump in." He says, "You sure? That's going to be like $4,000 for that pump." I said, "Put a pump in the ground, let's pump it, let's see what happens." And Gene said, "It's unbelievable. We filled that pit in like 3 days, Continued, never pumped down. Very beautiful water, exactly 40 feet difference, but we moved from where the water, where the pinpoint by the satellite says, we moved closer to the rig because I didn't want to be 800 feet from it. So it worked out perfectly. We've got as much water as we'll ever need to drill it, and of course we have, the oil and the resource below. We can
Just a quick comment on the water.
Yeah.
James says, drill the water here. It's like, dude, It's on top of a hill. Let's move the water down here in the bottom. I have irrigation wells just a mile away in the bottom. That's where we should probably go. But he said, no, this is where we want to drill it. It's like, okay. And so we did, and it is a really good water well. And so it's like, maybe this technology is working. So then when we drill the oil well, we're going to hit oil here. It's like, my family has owned land in this area for around 80 years, and we've been drilled on a lot, and all we have is dry holes. Now we have a hole out here that has oil in it, and it's like, maybe this technology's got something going on. You know? And while I got your attention, just one more comment. This was pasture, April 1st. Everything you see here was just pasture. There was nothing here on April 1st. April 3rd or 4th, I rented a bulldozer and started digging the ponds. We have the High West brought electricity in. We got 4 power poles. We have 3-phase electricity here now. We have a water well. And then now we have a sewer system out here. We put in a septic tank and a leach field for our man camp. And we got the pad. We drilled one oil well, 7,500. Took that rig down. This rig was sitting in Fallon, Nevada, on June 20th. June 20th, I started moving this sucker here with a bunch of neighbors, semis. 45 semi truckloads later, it's sitting here. It's up, and that thing was up by July 31st. Wow! So we get stuff done out here, and we can duplicate it. For now, I got the rig here in Nebraska, and we got all these other targets. We can duplicate it a heck of a lot quicker than what it's taken so far. But everything you see has been done in 4 months.
That's incredible.
So, yeah, I mean, when we first got here to do it, it was snowing.
Everybody keeps telling me that, and you told me how cold it was, and we came out here, and I got sunburned like a son of a gun.
One of the technologies that we control is a oil cleaning technology, and I want to talk about that for a minute because the whole industry has now gone to solar because they want clean energy. We have a technology that can take oil that looks like this. This is very contaminated oil. And we can turn that into this. And you'll notice that this is the same jar. And this area here is coffee colored. So we've completely changed that oil. And the top, all the contaminants are in the bottom of the jar. All the metals, we had phosphates of 2,700 ppm, got it down to 1 ppm. We had copper of 600 down to 2 ppm. Lead, which of course they're trying to get out of it, eliminated the lead entirely. And we can do this with ease. It's not something that is tremendously difficult, but it's proprietary. And the oil that we're going to produce here will be coming out as the greenest, cleanest oil that you could have in the environment. And we've tested, we've got lab tests, we've got it all blueprinted. We know what to do. So we want to be known as a company that's environmentally conscious. We've got very good oil. There's an aspect of this to carbon credits, which we're going to take advantage of, which is extendable to what you're doing with your point. And we believe that it's going to be revolutionary to the business. We're going to get a higher price for the crude. We're going to get higher BTU in the oil. So BTU determines exactly what you get paid, and of course, when you burn this in an automobile, exactly how powerful that is, right? The premium gas is higher BTU gas. We found the largest metal deposit in North America. This is a giant pipe. It's a bulkhead. You've probably seen on National Geographic the smokers in the bottom of the ocean. There's millions of them. What's happened over time? Pangea was one nation, and then it broke up over time. It went over these pipes. And those pipes, when those plates go over these pipes emit methane gas. Methane gas, the earth is filled with methane gas. And the chemistry behind this is that these smoke as they're coming up, they hit the base of the crust. The base of the crust has a mineral called serpentinite. Serpentinite is a mineral related to the asbestos family. And you may know from your history, those of you who've studied history, 1945, United States, in fact, Europe, we blew up the refineries in Germany, in the German-US war. And they were able to create gasoline after we blew them up, and we could not figure out how. But there's two scientists published, Fisher and Trop. They used serpentinite and natural gas under pressure, and they converted that to oil. The Earth is doing the same thing every day. This is where oil comes from. From those who think it comes from bugs, it's not true. What happens is the bugs want to eat the oil just like you eat oil, okay? And so the bugs move in. And there are organisms that they have found that will produce oil, but not on the volumes that we know have to come out in order to produce, you know, the millions of barrels of these fields. Okay, so we know we can. First of all, we have definitive proof in this pipe here because we have identified the largest oil target in North America. I'll show you that. By the way, this whole blue section here is platinum. These are 20-acre claims. This is rhodium. Okay, we have 80 acres of rhodium, by the way, goes for $21,000 per ounce. The total value of this pipe, if you have 1 gram of metal, is $6.6 trillion. Just to put it into perspective how big it is.
Wow.
The oil deposit that we've identified is here. Okay. Now, this is the pipe I just showed you. The color's been overlain, so you can't see it in the same colors that I showed you, but this is a separate oil field. It's coming out of this pipe. We found 4 pipes we've identified in this area, responsible for producing the largest field that we found in North America. The violet area here is 1,000 feet thick, 12,789 to 13,354 is natural gas. That's 900 feet of natural gas. 8 square miles in size.
Is this here?
To put that into perspective, that is twice the size of the Bahrain field in the Middle East.
This is here?
This is in Nevada.
Oh,
This is
Nevada.
Nevada.
How many times? Wow.
Is twice the size of the Bahrain field.
I've got a question. So the scan technology makes all this possible.
That is correct.
Wow.
Thank
That's
you.
correct. And the lower deep violet is natural gas liquids. That's 18 square miles in size, 100 feet thick.
Jeez.
If you do and this is oil here that we are drilling. We drilled well. We're continuing to drill this next week. We've just been given approval. We're at 6,100 feet. We've already intercepted oil in the first chamber that we identified here, and we are literally 1,400 feet from an oil pool that is 100 billion barrels in size.
In Nevada.
And we also drilled, by the way, the metal, these veins you see here. These veins go right through our well pad, and I drilled those veins, and we have the assays on them. The assays are a half ounce of PGM metals and an ounce of gold. Okay, and we also went through a pool of metal underneath our rig. The rig literally drilled through it. And we have copper and gold at 1,100 feet, and it is the richest plating deposit on planet Earth, according to our XRF. We have about 4% in that deposit. So very, very, very rich. If you take the oil deposit here, which is 1,000 feet thick, and you do the numbers, we have estimated 580 million barrels of oil in that, just the oil deposit, not including the secondary deposit here. If you calculate the gas, the equivalent of this, you have about $800 billion worth of natural gas, and you have about 400 billion in natural gas liquids. Altogether, at $25 oil, you have about $1.7 trillion. Let me back up. We also have identified helium gas, enriched helium gas in both the liquids and the natural gas. And when you take that into account, you get about 800 billion more. Okay? So we have what we estimate is the biggest deposit in North America.
So who owns a Nat G license? Just out of curiosity, who owns a Nat G license? just wanted to. Okay, just wanted to double check here.
Hey James, we got a time crunch.
Okay.
To get back. So
Okay. Well, I'm done unless you have any questions.